Hello, everybody, and thank you very much for joining our technical webinar this afternoon, or possibly it's the morning where you are, or maybe you're listening to a replay later. So first of all, I'll just move forward and explain a little background in terms of practical matters. So the webinar is being recorded, and if you've registered, you'll be sent a copy of the recording pretty soon after the event. In addition, we have Q&A features. So if you'd like to ask a question at any point, please do feel free to put a question in the chat channel. In addition, we have a dedicated time at the end for questions. So if you'd prefer to wait, do feel free to wait until the end, because there is going to be time to ask questions. What I'm going to cover today is, first of all, a bit of a big picture overview of AI, because it's a very large topic. And I'm going to explain how the technology that we use here at Yewno fits into that. Then I'm going to talk a little bit about the challenges that we face and how the use of artificial intelligence can help us all. I'll go into a bit more depth about knowledge graphs and very specifically AI-based concept search and how it's different. And then I'll move on to how it can be useful to help people with their discovery. So first of all, what is AI? So here we have this word chart here, and you can see it covers a huge range, and it's a very, very broad area. So anybody who works in any of these fields can legitimately say that they're working in AI. At Yewno, we're very specifically in the knowledge graph space, which is a blend of computational linguistics, machine learning, and graph theory. And I'll go into some details about that next. But just to be clear, we're not in these other areas, but they are all parts of the larger AI domain. So why am I here talking about AI and how it can help us in terms of discovery? So looking at the screen in front of us, we're all overwhelmed with the volume of data that simply exists today and the fragmentation of all the different places that we might go to look for that data. And what AI is brilliant at, it's brilliant because it has unlimited capacity to ingest and read all of the data that is being produced every minute of every day. And it can also go back as far as content has been digitized and take all of that historic data as well. So it can go way beyond what any individual could possibly do, and even beyond what teams of people can do in terms of ingesting and understanding content. So I'll move on now to very specifically what we do at Yewno in terms of how we take unstructured text and how we turn that into a discoverable environment. So what you see in this diagram, moving from left to right, on the left-hand side, you see content, and it can be any form of unstructured text. So it could be a short piece of text, like a journal article or a piece of news. It could also be a longer piece of text, something like a book or a book chapter, a report. And all of the text will be ingested as often as it's published or updated. And then what you see happening in the middle is a series of algorithms. And what the algorithms are trying to do is to recreate a neural network model in the brain. So they're trying to digest and recreate what would happen if any one of us on this call were to read the same information. So they're reading through and they're understanding meaning in the form of concepts. And as the algorithms read and they identify what they think is a concept, that will be promoted and it will go through a series of validation steps, and then it will be added to the knowledge graph. And I'll explain a little bit more about concepts in a couple of slides. And then on the right, we see a knowledge graph. So it's a multi-dimensional semantic vector space. And the key thing about a graph is that it's a fantastically flexible mathematical instrument. And different people and different researchers and students can look at it from different ways in terms of whatever their area of interest is. And the other critical thing about the knowledge graph is that it's not static, it's dynamic. So as new content and new connections are made, they're continuously updated. And the other key thing about a graph is that content is connected, and the graph is able to store relationships and connections in a completely new way to a traditional database structure. So moving forward, I wanted to show you this, and as you can see in front of you, all the lines are moving. So just to make the point about content being very dynamic and being constantly updated. So what you're looking here is news content that's being ingested in real time. And as you see each of the lines in front of you move and change, this is the different relationships between these concepts in real time. And it's looking at trade wars as an individual concept and how its relationship with each of these different things is changing literally in real time in front of us as we can see it. So not all content is this dynamic, but hopefully that gives a sense of a knowledge graph and how it can ingest data and how it can keep it up to date dynamically. So let's talk a little bit more about the concept-based approach. So why do we adopt a concept-based approach in terms of our technology, and how do we think that's helpful to discovery? So the key thing about a concept is that it carries with it a significance, and it can also carry inference. So all of us on this call can infer. We can have a hypothesis that certain things are connected, and that's based on all of our knowledge that we have today. And this technology, using a knowledge graph, can do a similar thing. So based on the volume of content that's been ingested, understanding the concept by its definition, it will have a significance in terms of its relationships, and the knowledge graph can infer, in addition to what it has read in the text, which is a direct connection, it can confer if there is actually an inference or not. So it goes way beyond kind of standard intelligence. And what exactly is a concept? So a concept is different from a traditional keyword in semantic metadata because it carries with it a definition. So if I were to say to everyone on this call, what is a jaguar? Some people might be thinking about Jaguar the animal. Others might be thinking about Jaguar the tank. Others might be thinking about Jaguar the car. There's also Jaguar the software. There's a drink called Jaguar, and there's also an athletic program. So the word itself, the label, is not enough for us to know exactly what we're talking about. So a concept is an atomic unit of information, and it has to have one, at least one, if not more definitions, and it can be associated to one or more topic. So on the left-hand side, we can see a picture of Jaguar the animal. We can see a definition of that. The jaguar is the largest cat in the Americas. It has a compact body, a broad head, and powerful jaws. And we can see that that can be associated to the topic of nature, the subtopic zoology, or the topic of nature with a subtopic of wildlife. On the right-hand side, we can see a different jaguar, same word, same term, but different definition. So Jaguar is a luxury vehicle brand of Jaguar Land Rover, a British multinational car manufacturer with its headquarters in Whitley, Coventry, England. And we can see that that is associated with the topic of engineering and the subtopic of car, and the other topic of marketing and brands. So same label, totally different meaning. So how does the technology do this? So in terms of extracting new concepts, on the left-hand side, you can see a piece of document text. Quantitative easing is a type of monetary policy used by central banks to stimulate the economy when standard monetary policy has become ineffective. And so what we're showing here with the words highlighted in purple is that monetary policy has been identified algorithmically as a concept. So it's been extracted from the text as a candidate concept, and it's been promoted. The next stage is it goes to a description lookup. So it looks for a reference source. So you know, we don't make up reference sources ourselves. We would only use a published reference source, and we would always have at least one open access source, possibly multiple open access sources, and then further licensed sources. And if we can match the concept with a definition, then we'll automatically be linked. And if there's a concept and we cannot find a definition automatically, which is a very small number, it will go into a manual queue to be reviewed by a human. So to give a further example of why this disambiguation is so important, if I were to say the word depression, I could be talking about a wide number of things. I could be talking about a depression in geology. I might be talking about a depression in meteorology, a low pressure area. I could be talking also about an economic depression. If I was to be talking about an economic depression, I might be talking about the Great Depression. I could be talking about the Long Depression, or I could be talking about the Depression of 2021. Equally, I might be talking about a totally different kind of depression, depression in the mood. Or I could be talking about a depression in physiology, or equally major depressive disorder. So we can see that the term depression itself isn't enough. And after this call, if you go away to different search bars and you take a look, some of them will not offer you any options other than depression, in which case when you get your results, you'll get a complete mixture of things. You might be getting something talking about an economic depression, you might get something talking about the Great Depression or the mood depression, but those things will all be mixed up together. And as we know, we're all overwhelmed by the volume of information already. So what the technology is able to do using disambiguation is to help people find what they're looking for in a very precise way. And beyond the document itself, it can also take you to the exact section of text. So how does the technology actually help, again, in terms of getting us to the section of text? So because all of the documents are going to be read algorithmically, when you find what you're looking for, you can be directed not just at title level, but actually to the section that refers to the concept you're looking at. So if we look at the first example, this was a search for 3D printing. And in the content, the word 3D printing wasn't actually mentioned, but because the algorithms had read and understood it, and because the word had changed over time, but because a concept has a definition, it understood that it was actually talking about 3D printing, even though the term wasn't mentioned in the text. So in this way, you can help people find maybe older text and things where the language has changed a little bit and it's something different. So you can help people find things that might otherwise be hidden when you're doing a traditional keyword search. The other thing is really helping people as language has evolved. So most of us would have talked about the United Kingdom withdrawal from the European Union, but in about 2016, the term Brexit was widely used. It had been around for a long time before then, but it came into broad use at that point. So if you were doing a search for Brexit, all of the documents about the United Kingdom withdrawal from the European Union would have been very relevant to you. But if you put in the term Brexit, you would hope that all of those would also be surfaced. Equally, if you were to use the term United Kingdom withdrawal from the European Union, Brexit would be very relevant for you. And so much better if algorithmically technology can identify all of the relevant things, even when the user might use a slightly different term that is pertinent to them and how they would use or speak and use the language. On the right-hand side, we see an example, a scientific example. There is a drug called Nurofen, and its actual correct name is ibuprofen, but a researcher might not know that. And so if they were to use either term, they'd want to have that option to get to all of the relevant literature about that specific item. So finding relevant content is critical. And one of the biggest researcher frustrations is searching and spending hours searching and actually not finding what they're looking for. So being able to direct people to something that actually matches their query in an efficient way and helping people have more effective research and enjoyable research is a huge leap forward. So in this example, I'm showing 3 ideas of potential searches that somebody might want to do. So the first one is estimation theory. The second one in the middle is activism. And the third on the right-hand side is workplace culture. So those are concept level terms. They're very granular. They're not terms like engineering or artificial intelligence or science or medicine. Nobody would be looking at that level. They'd always want something much, much more granular, much, much more detailed and related to their research. So moving on, and how can knowledge graphs help discovery? So if we look at what's happened with technology, where we started, how we progressed over the past several decades, and how we've got to where we are today, we started off as content was printed with BISAC and keywords. And BISAC codes were designed to help people find a book on a bookshelf. And keywords were designed to, again, help the search. And keywords have been produced inconsistently over time. So they might have been produced by an author. They might have been produced by an editor. Some items of content will have more or less. So when you use them to rank in a digital world, the results are not necessarily equally distributed. And then as time went on from the early 1970s, natural language processing came about, and it was a huge step forward in terms of a machine being able to take text, identify terms, and look at things like statistical distribution. But the technology was not actually understanding what it was reading, and so it couldn't give that context or perspective or disambiguate. And if you look at where we are today, on the right-hand side with deep neural networks, algorithms can not only scan the full text, they can read and understand. They can understand context, and they can accurately disambiguate at concept level. So you can help people find not just the term they're looking for, but the correct definition of the word. And what we're showing in the little graph above the text is various concepts that have been promoted into a vector space close to other related concepts. So if, for example, a machine is reading a text and it mentions the word apple, it can understand from the text surrounding that it's apple the fruit. And it would then project that concept into the graph network close to similar concepts, maybe other fruits like pear. And so you can see in the top right-hand corner, those two concepts, apple and pear, close to each other in this virtual vector space. We can also see another apple, same term, but again, this time it's talking about the company Apple. And the algorithms have understood that, again, because they've read the full text, and they've understood that that Apple was actually talking about potentially software and other technology companies, and it's been projected into the vector space close to Microsoft and Java, the programming language. And those are all of those concepts in orange. But if the machine was to read Java, it might indeed be talking about a programming language, or it could also be talking about something like Java the island. And again, it can understand which one it is because it's reading the surrounding text, and it's understanding in the same way that the human brain would understand. So that's how you can get the accuracy and the precision in search. And if you look at the text below, which is tagged as interment, it doesn't actually mention the word interment, but it's absolutely about interment because, again, it's understood what was going on. So looking at some very specific examples of how technology can help develop research skills in the first use case. So undergraduate students may well start a new course and not be particularly familiar with all of the terminology, because by definition, they've just started working and researching on a completely new subject. So what's very helpful about the technology is that it can give you results about the term that you do know, that you've entered into the search bar, and it can show you all of the relationships, all of the related concepts. And that gives you a sense of context and perspective. And all of the connections you can see here are interactive and clickable. So whatever interests the student or the researcher, they can click into it and they can investigate further, and they can keep going and keep clicking and go as far as they like and drill down really into that area. And it can be very helpful in terms of helping further shape a search query and help shape good research questions. And the knowledge graph itself, the visualization, is very engaging and provides a completely different way to look at information. And it's not possible to see connections in any other way. So if you think about a traditional search tool and a list of search results, it's not showing you how each of those items in the list is connected to each other. When the researcher is ready, they can also move, you can see on the left-hand side here, to the cryptanalysis panel, where we have an overview, a list of concepts and documents. So at that point, when they do feel ready to move into the documents, they can move into the documents about any concept individually or any concept relationship. So very helpful, first of all, in terms of giving people a broader sense of concepts that might be interesting to them and helping them to expand their search query. Another area where it's very useful is interdisciplinary research. So there are many cases where there are brilliant content sources, but they're very specifically about one area. And so if a student wants to look at two different areas and how they can connect in, it can be more challenging. So here what we can see in this picture is a search for developmental robotics, so in the field of engineering, and a link there with psychology. So if you started looking at really high quality engineering information, you would be just looking at engineering. It would be much harder to make that connection, whereas the knowledge graph helps open up and helps people find connections that might otherwise be buried in literature. Very often, it could be a non-obvious connection, and it can really give people ideas that they wouldn't have thought about in the first place. Then the third use case is really around serendipitous discovery. As content has grown in terms of volume, people have learned to hone their search and narrow down to try and get the search list to a more manageable number. And by doing that, you've by definition also excluded anything that's not directly related. And to a certain extent, although digital resources are brilliant at some things, that does take away a little bit of the serendipity around some of the discovery. So if you think about a day when you might wander around a library or a bookshop at the airport or in the high street and come across something that you hadn't actually gone in to look for, but you'd found by chance. So what you can see here is that the ability of the technology, first of all, to visualize and to show connections in this way, and also because it's based on knowledge graph infrastructure and it's connecting everything, it will come across all kinds of things that people were not necessarily expecting or not knowing that they were connected. So here we can see all these interesting connections. And the big blue concepts are the connections that the researcher has entered. And then all of the smaller gray ones are the connections that are either directly between those or indirect connections. So it can help people discover things that are relevant to their research that they weren't actually looking for at the beginning because they didn't know that they existed. So how can we integrate this new technology into the existing library research ecosystem? So what I'm showing you here in the slide in front of you is really how it's designed. It's not designed to replace what exists. So if you use an existing traditional search tool, you will still need to use that for known item searching, but it's designed to complement that by bringing in a new angle, a new dimension, a different way to visualize information and help people in their research. So in the top left, you can see an integration with Primo. And remember that the integration is, of course, interactive. So you can click on anything you see in the mini knowledge graph called Yewno Relate. And you can also change the concept from the knowledge graph itself. And then on the top right-hand side, you see an example of quick search. On the bottom left, you see an integration with Circe Dynix's Cloud Source OA. And the graph here is on the right-hand side. And then the bottom right, you see an integration with EDS. And it can be integrated really with a straightforward piece of JavaScript code into pretty much any interface. And it's designed to complement the existing infrastructure and the existing ecosystem and bring AI into it and help researchers to find things. So I'm going to open out to Q&A now. I can see I've got a couple of questions in the chat already. So I'll answer those and then I'll talk a little bit about next steps. So the first question is, are the tools that Yewno provides designed to replace a library discovery tool? So no, they're not trying to replace the tool. What they're trying to do is to add something new into the ecosystem, to add, first of all, that visual component, and then to use AI to come up with a way to show connections and relationships, because content is connected inherently. And it's incredibly useful for a researcher to be able to see those connections and then interrogate them. Because knowing that two things are connected is not enough. You need to always be able to get to the source documents and the source literature. And so once you click on either a concept or a connection, you're able to drill down and actually get to the documents and that mention those concepts and those connections and understand that connection itself. So the next question is, where do you get your concept list from? So in terms of concept lists, we ingest a wide range of reference sources, always open access and licensed sources, so that if somebody doesn't have a subscription to a licensed source, they will always find at least one definition for a concept that they're researching. And in addition, the technology itself searches for concepts, it searches for meaning and promotes those. And so if it were ever the case that a concept was identified by the technology and we couldn't match it with a reference definition, it will fall into a manual queue. And one example we had was neurophotonics, where we couldn't find a definition and we referred back to the publisher to get a definition. And early on in November 2019, a new concept was COVID-19, and that fell out. And again, we found a definition for that. The next question is, how many concepts do you have? So the concept universe at the moment is over 5.5 million concepts. It's forever expanding and growing. And that's one of the great things about knowledge graph technology, is that it continues to evolve and grow and learn as more content is added. The next question is, how many documents have you extrapolated concepts from, and what type of documents? That's a great question. Thank you very much for that one. So our objective in this tool is really to ingest across all different domains of content and to ingest across a complete range of unstructured text. So we have a huge range of journal articles. We have comprehensive coverage through Microsoft Academic Graph now, OpenAlex. So we have all journal article abstracts in full text. We have about half of all journal articles in the actual full text themselves. So the full journal article in addition to the abstract. When you think about a journal article abstract, you can normally extract about 12 concepts from that, which is actually very good. So traditional metadata often has only 3 to 6 concepts or keywords per journal article. So that's already very good. And of course, if you have the full journal article, you might be looking at 70 or 80 concepts per article. Then we have books, chapters, news. We also have the capability for anyone who owns their own content set, whether that's a university or some kind of corporation or institution. If you want to include that in the knowledge graph to be able to visualize your own content in the context of other information, unique content sets can also be included like that. So hopefully that answered the question on types of documents. But if you are interested more about that, do feel free to write in and we're happy to send you further information on that. Next question, how long does it take to set up? So in terms of getting set up, it's a very straightforward process. It's not like installing a new sort of traditional discovery system. We have a piece of JavaScript code, which takes about 15 minutes to install on your website. If you want us to have access to your licensed content so that your students can make better use of your internal resources, we would ask you for a copy of your link resolver holdings. It's a standard file, so not something new that you would need to create for Yewno, but something that you would already have. If you wanted us to show your logo, we'd ask for a copy of your logo so we can make it personalized. We'd ask for your IP ranges so that we can give correct access to all of your community. And we'd work with you to integrate whatever authentication you use, whether that's Easy Proxy, Shibboleth, or Open Athens, to make sure that people can access the product and have a very seamless experience. I've got another question here. Will you ingest the library holdings listing? Yes, we would ask you if we could have a copy of your link resolver holdings file. And the idea would be that that gives us a complete list of all of your licensed content. So as somebody is doing their research, if they find a document that's covered by your licenses and they click into it, they'll get through to the full text and you'll get better use of your subscribed content. Next question, will Yewno Discover ingest our university repository? So that's an option. It's not part of the standard product. It is an additional chargeable feature, but if you do have a repository and it's in a good quality digitized format, and that's something you would like to have either visualized in the product, or if you would like to have enhanced semantic metadata returned to you so you can make that content discoverable in your existing platforms, either of those two are options. So I'm just going to have another look in the chat, I think further there. So I'm now looking in the QA. So I have the first one. Hello, can the system manage foreign languages? So at the moment, it is in English. We do have content submitted in other languages, and we can use Google Translate to then make that content discoverable in the platform. We've done quite a wide range of languages now, and if you're interested further about that, do let me know, and we can get back to you. And the second question is similar. It's what about languages other than English? So yes, we would probably use Google Translate, but if you have a very specific query, do feel free to send an email and we're very happy to get back to you on that and explain how it works. So I'm not seeing any questions at the moment and we have 1 minute left. So I'll use that time to say, first of all, thank you very much to everybody who's joined us here today. If you're interested in our next webinar, that's going to be about finding content from your repository or local collections and how that can be integrated into the knowledge graph environment. And we'll be scheduling that for a date in June. If you happen to be going to UKSG We'll also be there and we'd love to meet up with you. So do let us know. And if you've got further questions after the webinar, please email into william@yewno.com and he'd be delighted to get back to you with any answers to your questions. So once again, thank you very much, everybody, for joining us here today. I hope it's been useful and we'll be sending you a recording shortly. Many thanks and have a great rest of the day.